Hello there, welcome to lesson number 1 in our series on using FluidDesigner for 3D printing to create bracelets. In this lesson we're going to show you how you can use a simple torus mesh to create a basic simple bracelet. So if you start FluidDesigner up, first thing we need to do is to go to Learning Projects, Jewellery Projects, Bracelets. And we're doing lesson number 1, so we want object, it's O1, a simple torus bracelet. And if we drag and drop that onto the workspace, this is what we're going to recreate in today's lesson. Now I've just switched on screencast keys, so any key presses I make should be displayed here for you, which may help you as we work through this video. If I just zoom in on this object, at the moment it's, if we look in the properties panel over here, there's some X, Y and Z values. Well, the Z value is the easiest one to explain. Z is the blue arrow direction, that's the vertical as we're looking at it at the moment. So a Z value of 6 millimeters means from the top to the bottom, the height of this object is 6 millimeters. The X direction is the red arrow. Okay, so the value 66 is the distance from the outside edge of the torus on that side through the center to the outside edge on this side. So it's the external diameter of the ring. Now when you're creating a bracelet, the internal size is the important dimension that you need to know and set when you're before you print an object. You do want to know what the internal size is. This is the external, and the 66 is the Y direction, and again it's the distance from the outside of the torus on this side through the center to the outside of the torus on the other side. But these values are important. The thickness is really important. You can see that straight away. This gives you an idea of the size of the object, but we will need to modify it to scale it at some point before we print it, so that our internal diameter is what we need to record. Okay, so how are we going to create this object? Well, in the help instructions here it says add mesh and add a torus. So if we go to add mesh and select torus, now it's very important that this window here, this toolbox as it's referred to, is open. If it's not open, if you press T on the keyboard, okay, so if I press T again, it will open up the toolbox, and pressing T will also close it. Alternatively, I could click on the plus sign there to open it, or drag it across to close it. Now in this instance, because we're working on this torus object, it's very important that this information is displayed. This panel can be adjusted so that you can look at the 3D printing functions within FluidDesigner. We, however, want this information displayed because we're going to change some of these values here. Okay. So, what are we going to do? Well, if we go to View and Zoom to Selected, first of all, we can actually see what this torus shape looks like when we zoom in. And the only thing about it is it's very small at the moment. It's only 2.5 millimeters by 2.5 millimeters. So the external dimension here is 2.5 millimeters. And the external dimension here is 2.5 millimeters. So that's really not big enough to even put on your little finger. So we need to resize it, but before we resize it, we're going to change these values here called major segments and minor segments. Now the best way to understand what the major segments are is if I actually hold down the left mouse button and drag the mouse to the left, I'm reducing the number of major segments. And as you can see, I've taken it right down to 3. So 3 major segments mean that's 1 segment, that's 2 segments, that's 3 segments. So the major segments are the number of segments going around the outside of the object. So if I change this to 4, you can see I've got 1, 2, 3, 4 segments going around the object. 5, 6, etc. Now, one of the nice things about this torus object is that you can create shapes like a pentagon. This is a 5-sided shape, a pentagon. So you could create a bracelet that's a pentagon shape. Although we're using this torus object, we've done add mesh torus, and here it looks like it's a ring. Well, the torus is a ring, but if you reduce the segments right down, you can come up with some of these basic shapes like triangles and squares and pentagons. So the lower this value is, the smaller the number of sides going around it. Now, if you wanted a really perfect circular object, you need to make this value very high. So again, if I hold down the left mouse button and if I drag this up, you can see I can go up into the hundreds. I can go up to 256. So that is a very rounded shape now because it's got a lot of segments going all the way around it. Now we want to set the major segments at 60, so I'm just going to enter in a value of 60. So if we zoom in, this bit here is one segment. This bit is another segment. This bit is another segment. So we've got 60 of these going around the object. So it is a little bit chunky. But you know, you've got to decide on the style that you want. Now the minor segments, well, we're going to leave it at 12, but let's explain what it is. Again, if I take this down, and 3 is the lowest I can do, the minor segments are the number of segments going around in this direction now. So there's one here, there's one at the bottom, and then there's one face on the inside. So there are 3 segments, 3 faces going around. So if we do it to 4, there are now 4. There's 1, 2 on the here, and then there are 1, 2 on the inside, making a total of 4 minor segments going around it. So again, the higher this value, the more rounded the shape becomes, because we're increasing the number of segments going around it. So again, you can take this value really high, and once you get up into the hundreds, you'll see it does look very smooth at this point. But what you do have to take into account is that, you know, the number of faces that make up this object increases quite dramatically when you do that. 13,000, 14,000 is not a bad number, it's okay. But anyway, we're going to set the minor segments at 12 in this instance for this particular exercise. So the next thing we want to change is the major radius, and we're going to set the major radius at 30 millimeters. Well, if I click on here now and just, you can see exactly what the major radius is doing. It's increasing the size of the object, which is clearly what we need to do if it's going to fit round our wrist as a bracelet. Now the major radius, 7 millimeters, well, let me just take it down to, let me take it down to say 5, and then I can try and show you what it is. Okay, the major radius is actually the distance from the center to the middle of the ring here. So if we count them, we've got 1, 2, 3, 4, 5 millimeters is to the middle of the ring. It's not the outside, it's not the inside, it's the middle of the ring. So if the major radius is 5 to there and 5 to the other side, when we look up here at the value of x, the value of x is the distance to the outside of the object. Well, we've got another 0.25 thickness here. That's what the minor radius is. A 0.25 thickness here, which gives you a total of 0.5. So we've got 5 millimeters to the center, plus another 5 to the center on that side, that's 10, plus 0.25, plus 0.25. You add all of those up, that's where the 10.5 comes from. Okay, so the major radius, it's to the center of the torus ring. So we need to take this up to 30, which will give us an approximate internal size of 60 millimeters, but we will adjust that later. Now if we zoom in, this is currently a thickness of 0.5 millimeters, which is too small to 3D print. So what we're going to do is we're going to take this value up, we're going to increase the minor radius, and you can see what's happening. The thickness of the ring is increasing, Okay, now it does look quite bulky, but it's because, you know, we're zoomed in. Now we want a value of 3 millimeters, and you need to type 3 mm, otherwise it won't work. And 3 millimeters, what that actually does is it gives you it's actually the radius of the object. So it's 3 millimeters from the grid to the top, and it's 3 millimeters from the grid to the bottom. It's the internal radius of this torus ring. So 3 millimeters to the top, 3 millimeters from the grid to the bottom give you a total thickness of 6 millimeters. So that's what you get there. Okay, so those are the only changes we want to make in this toolbox panel here, so we can actually shut that down now. Now I'm going to highlight this object, and I'm going to get rid of it now, and we do that in FluidDesigner by using X on the keyboard. X is the delete object command in FluidDesigner, so if we delete that object, that just gets that out of the way. So this is the torus we've created today. Now if we were printing this for real, the important dimension that we need to know is the internal dimension. So if we wanted an internal diameter of 60 millimeters, we need some way of doing it. Well, if we view this from the top and zoom in, one way of measuring it would be to use the interactive ruler. And I've just scrolled across the toolbar by scrolling the center mouse button. And if I click on interactive ruler, I can measure the internal diameter of this. Now that's about 55 millimeters. So if I wanted an internal diameter of 60 millimeters, I need to resize this. Now there are some instructions in here on different ways of doing this. The best way of doing it in FluidDesigner is really to actually add another object to this workspace. And if we add a cylinder to the workspace, now at the moment the cylinder is very tiny, but if we change the dimensions of the cylinder to 60 millimeters, so that's the external diameter of it, and 60 millimeters, and if we just give it a little bit of thickness as well, 20 millimeters, and I just zoom out, you can see I've created this cylinder there. And I'm going to use that cylinder to resize my torus ring. And what I need to do is just go back to view and view it from the top again, and zoom in a little bit, and I just need to reposition it slightly. The bigger it is, the better. Now if I click on this torus now, and I must make sure that I've got the torus ring highlighted, I want to make this slightly larger so that I can just see the gap between the torus ring and this cylinder. The cylinder diameter is 60 millimeters. So if I press S on the keyboard, S on the keyboard is the scale function in FluidDesigner. I can scale up the torus ring look, and what I'm looking to do is to move it until it just fits around the outside of that cylinder. And then I can click the left mouse button to accept it. Now, one thing to always be wary of in FluidDesigner is whenever you make something bigger, these values here, the resize vectors, will change from 1. These values, the scale vector values, should be 1. So you always, when you scale in FluidDesigner, you need to immediately reset the scale. And you do that, you do that by doing Control and A on the keyboard and applying the scale. And then you see a little tick in the box here saying that the scale is now okay. So whenever you resize, you must do that. Now we don't need this cylinder in the middle, so let me just double check the cylinder. I've highlighted the cylinder, so we can delete the cylinder now. We only use that to get the size, so it's X on the keyboard and delete it. So there is our torus now, and it's a little bit bigger in size than what we originally had. Notice the thickness has also changed as well. Now if we wanted to reset this to 6 millimeters, we could type in here 6 mm for 6 millimeters, but because we've scaled it, we must always do Control A and apply the scale. Otherwise we could end up with printing problems. So I've changed that and set that to 6. Now I don't want to change these values, they're the external dimensions. So my internal dimension is 60 millimeters in this example. You may want to do a different value depending upon the size of your wrist. So if you wanted 50 millimeters, you'd have to scale the object down from the original one we created. Now we now need to do a couple of other things. We need to save this. So if we go to File, we always say go to Save As in FluidDesigner. Don't save on top of the original file, go to Save As. Just go up through the menu system and look for My Projects, Jewellery Projects Bracelets, and you can save Lesson 01, the Simple Torus bracelet, as a Blender file. Now you can't print Blender files, so what you need to do is to go to File and Export. Now we like to use the Wavefront OBJ format, and I like to save these to the desktop. So this is the printable file format, and we export that to the desktop. Now we must always when using FluidDesigner, go to Netfab Basic, which is a free piece of software you can download from the internet. Go to Project and Open. Go to the desktop and open Lesson 01, the Simple Torus bracelet. And what we need to do in Netfab Basic is go to Extras and repair the part. And Netfab Basic is a mesh analysis tool, and it will check your mesh and it will make sure that it's printable. Now at the moment there are no border edge problems, no orientation and no holes, and there's only one shell. So that is telling us that everything is good. Netfab has, however, triangulated the mesh. These lines across here have been put in by Netfab Basic because we need triangles when we print. So all we need to do is to run automatic repair and execute it. Just check update again, it's still all zeros, and apply the repair and remove the old part. Now to a large extent we haven't really repaired anything in this mesh, but generally from FluidDesigner we do need to repair things. But we have triangulated the mesh, which is still important. So if we go to Part and export the part, export it as a wavefront object to the desktop. So this file, 01 Simple Torus Bracelet Repaired, that's the file you should send to the printer. So we just save that. So there it is. That's how we can create a simple Torus bracelet in FluidDesigner and check it with Netfab Basic. Okay, thank you.